All right, so I think I'm recording here. Let's take a look at solving these two absolute value inequalities. Um, these two problems represent two possibilities, two different cases. You notice that the arrow is pointing away from the absolute value in problem number one, and notice in problem two the arrow is pointing towards the absolute value. So that's going to be a critical thing that you look for when you're solving these. Get the absolute value by itself and then look at the direction of the inequality. So here, when it's pointing away from the absolute value of x, then I know on my number line, I'm going to be shading in the tails of my number line, similar to when we had the quadratic inequalities. When the arrow is pointing towards the absolute value, I'm going to be shading towards the center of that number line. So hopefully that'll become more clear as we go through the solution of these two problems. So we're going to split this up into a compound inequality. We drop the absolute value, we change the direction of the arrow, and we also change the sign. So we have x is less than or equal to -8, and then in the second inequality, we just simply drop the absolute value symbols. So let's sketch our solution set on the real number line. We've got -8 and +8, and those are our critical points, our boundary points, our endpoints of our solution set. We need to make a decision whether to leave these hollow or to shade them in. Just like before with the quadratic inequalities, we shade it in. We look to the arrow. If it's underlined, if it contains equality, then we're going to shade it in. If it doesn't, we're not going to shade it. So we can see in problem number two where this is not underlined. And in problem number two, we're going to see our critical point, these endpoints being hollow points, not solid dots like we see in problem number one. Values of x that are less than or equal to -8. To be less than or equal to -8, we shade to the left. And here, x greater than or equal to 8, we shade to the right. So that's what I mean by when I describe this as saying shaded in the tails. To write this in interval notation, the left arrow is shaded, so we have -infinity. There's never a bracket around -infinity. It's always a parenthesis. But here at -8, we're including that number, so we have a bracket. We use a union symbol in mathematics for the word or. So our solution set is members, x is going to be either in this set or it's going to be in this other set that is from 8 out to +infinity. So here's our answer for problem number one. Let's take a look then at problem number two. And here, when the arrow is pointing towards the absolute value, we change the sign of +10 and write -10. We keep the arrow pointing to the left here. We drop the absolute value, and then we say 10. So this compound inequality, you could, if you wanted to, split it into two inequalities with the word and, but I think it's condensed and easier to just keep it like this. The arrows are pointing to the left here. We've got -10, we've got +10. We've already mentioned that we're going to keep these endpoints hollow, that we're not going to include them in our solution set. And this compound inequality, we shade the center. Let's go ahead this time and write this in two inequalities to demonstrate what I mean, that we have that -10 is less than x, and at the same time, x is less than +10. I like to write these inequalities with my variable on the left-hand side. So I like to write that as x. The arrow is pointing towards -10. It's still pointing towards -10. So you can see that x greater than -10, I shade to the right. And at the same time, x being less than 10, I shade to the left. And that overlap, that intersection, is all the points that are between there. So to write my solution set, I'm from -10 to +10, excluding these endpoints. All right, so I hope that helps. Ask any questions as needed, and I will talk to you later. Bye.